differentiation mean? To show or find the difference between things that are compared. Differentiation is when we differentiate the equation fx to f prime x or the equation y to dy dx. Rules of differentiation. First is derivative of polynomial function. Here we have fx equals to x to the power of n. Differentiate this f prime x and x to the power of n minus 1. For example, we have here the question. We differentiate this into f prime x equals to 12x cubed. Second is derivative of composite function. Here we have y equals to u to the power of n, and we differentiate y into n u to the power of n minus 1 du dx. For example, we have the question here. We can differentiate y into this. The third is product rule. We have fx equals to uv to f prime x equals to uv prime plus vu prime. We have an example question here. First, we write down which is our u and which is our v. After that, we can differentiate them, and we got v and u prime. And then we just have to remember the formula and substitute, and next you just have to simplify it. Next is quotient rule. Here we have y equals to u divided by v, and now we differentiate y into u prime minus uv prime divided by v squared. Here we have an example question, and first we determine which is our v and which is our u, and we have to differentiate u and v. After that, we just have to remember our formula and substitute. All that's left to do is to simplify it. Next, we have exponential, logarithmic, and trigonometric function. First, we have y equals to e with the power of u. We differentiate y in respect of x into e with the power of u du dx. Here we have an example question, and here is the reminder of the formula, and we just have to substitute. All that's left to do is to simplify it. Next, we got fx equals to ln u. We differentiate this into f prime x equals to 1 divided by u du dx. Here we have an example question. Here is a reminder of the formula. All that's left to do is to simplify it. Third is the trigonometric function. This is the rules, and we just have to remember this.
First, we have to recognize that the given function y equal to 2x cubed multiple 10 2x plus 1 is a product of two functions. This means we need to use the product rule to differentiate. The product rule states dy over dx equal to u dv dx plus v du dx. Next, we let the first part u equal to 2x cubed and the second part v equal to 10 2x plus 1. Now we differentiate both parts separately. The derivative of u equal to 2x cubed is 6x squared. For v equal to 10 2x plus 1, we use the chain rule because it's a function within a function. The derivative of 10 2x plus 1 is dv over dx equal to second square 2x plus 1 multiple 2. Then we substitute everything into the product rule formula. Finally, we simplify the expression to get the final answer. Dy over dx equal to 4x cubed second square 2x plus 1 plus 6x square multiple 10 2x plus 1. First, we are given the function y equal to 2 minus 3x over 2 plus 3x square. To make it easier to differentiate, we write the function using a negative exponent. Y equal to 2 minus 3x multiple 2 plus 3x power negative 2. This is clearly a product of two functions, so we will use the product rule which says dy over dx equal to u dv dx plus v du dx. Next, we define the two parts of the product. Let's u equal to 2 minus 3x, so du dx equal to negative 3. Next, let's v equal to 2 plus 3x power negative 2, so we differentiate using the chain rule. Dv over dx equal to negative 2 multiple 2 plus 3x power negative 3 multiple 3, so equal to negative 6 multiple 2 plus 3x power negative 3. Then substitute all value into the product rule formula. Then simplify step by step. Then to combine both terms under the same denominator, we convert everything to half the power of 2 plus 3x cubed. After expanding and simplify the numerator, finally we factor the numerator. So we're gonna get dy over dx equal to 9 multiple x minus 2 over 2 plus 3x cubed.
For this question, we need to put d over dx into the equation. So from this, we can divide it into 4 steps. For step 1, we can use product rule formula, which is u v prime plus v u prime. So from this, we can say u is y power of 3 and v is log 3x. So we can search for u prime and v prime. We can use differentiation to search for it. So u prime is 3y power of 2 dy over dx, and v prime is 1 over x. Then we can put it into the formula. For step 2, we can use formula EU multiply with du over dx. So from this, 3e power 2x will be, if we differentiate it, it will become 3e power 2x multiply with 2. So the final answer is 6e power 2x. Step 3, we can use secant u formula, which is secant u tangent u du over dx. So from this, we can just use the formula and multiply it. And the final answer will become 3 secant 3y tangent 3y dy over dx. Step 4, we can use formula constant, which is 0. For the last step, we need to combine all 4 steps that we do just now, and we need to combine it followed by the equation. So from this, we need to put dy over dx at the left side, and the other equation we need to put it at the right side. So from this, we need to put out dy over dx multiply with the other equation, like in this slide. And then from dy over dx, and we multiply with the other equation, the equation we need to divide by the right side, and then we can find the dy over dx. So from this, for 6e power of 2x, we need to multiply with x over x. So from this, we can combine the equation that is negative y power of 3 plus 6 x e power of 2x over x, and we need to divide it by 3y power of 2 log 3x minus 3 secant 3y times 3y. So for 3y power of 2 log 3x minus 3 secant 3y tangent 3y, we need to change the division to multiply. So from this, we need to put as 1 over 3y power of 2 log 3x minus 3 secant 3y tangent 3y. So from this, we can multiply it as usual. So the final answer is negative y power of 3 plus 6 x e power of 2x divided by 3x y power of 3 log 3x minus 3x secant 3y tangent 3y.
We have 4 steps to use a linear approximation. We have step 1, define the function. We define fx equals to square root x minus 4 divided 4th root. This is the function we want to estimate when x equals 80.99. Step 1, define the function. We define f. Step 2, choose a nearby simple value. Step 2, we choose a value near 80.99 that give a nice square roots and 4th roots. Let's say x equal to 8099. We choose x theta equals to 81. Why? Because square root 81 equals to 9 and 4th roots 81 equals to 3. Now, we write f prime x equal to d over dx bracket x power 1 over 2 minus 4x power negative 1 over 4 equals to f prime x equals to 1 over 2x power negative 1 over 2 plus x power negative 5 over 4. Step 4, linear approximation formula. We use this formula. F bracket x plus change of x bracket equals to f bracket x theta plus prime x theta multiply change of x. Now we need to substitute f bracket 80.99 minus 0.01 equals to 23 divided 3 plus 0.05144 multiply negative 0.01. We can get the final answer 7661. It because the question asks for two four-decimal places.
In summary, differentiation is a fundamental concept in calculus that allow us to analyze how functions change. Throughout this presentation, we have explored various techniques of differentiation, and we have demonstrated the application to step-by-step problem solving. These techniques are essential for solving real-life problems in fields such as physics, economics, and engineering. By mastering this method, we can gain a deeper understanding of how rate of change influences the behavior of function. We hope this presentation provided a clear and insightful overview of differentiation techniques, and we encourage further exploration of this topic to enhance mathematics skills.